Hi all, welcome to my YouTube channel again. Today we are going to discuss about decimals, types of decimals. Decimals are broadly classified into two types. First one, terminating decimals. Second one, non-terminating decimals. Again, non-terminating decimals are classified into repeating decimals and non-repeating decimals. Hi all, welcome to my YouTube channel. Today we are going to discuss about decimals and their types. According to the definition, decimals are the numbers that have a whole number part and a fractional part separated by a decimal point. Here 123 is the whole number part, 78 is the fractional part separated by a decimal point. Got it? Also, in this case, 7 and 8 are called decimal digits. Example 1, 7.5. Here, 7 is the whole number part and 5 is the decimal part or fractional part. Example 2, 0.25. Here, 0 is the whole number part and 25 is the decimal part or fractional part. Observe here, the decimal part can be written as a fraction. Here also, the decimal part can be written as a fraction. So, the decimal part is also called the fractional part because it can be written as a fraction. Got it? As of now, do not worry about how to convert decimals into fractions. We will learn in detail in the chapter decimals. Tomorrow, we are going to learn about types of decimals. So, please stay tuned with me. Thank you. Hi all, welcome to my YouTube channel again. Today we are going to see types of decimals. Decimals are broadly classified into two types. Number 1, terminating decimals. Number 2, non-terminating decimals. Again, non-terminating decimals are classified into repeating decimals and non-repeating decimals. We will look at all these types in detail. First one, terminating decimals. The definition says terminating decimals are the decimals that have a finite number of decimal digits. Got it? Look at the examples. In 1234.45, 4 and 5 are the decimal digits. So, the number of decimal digits equals 2, which is finite. Therefore, 1234.45 is a terminating decimal. Second example, In 0.0034, 0, 0, 3 and 4 are the decimal digits. So, the number of decimal digits equals 4, which is finite. Therefore, 0.0034 is a terminating decimal. Next example. In 987.0, 0 is the decimal digit. So, the number of decimal digits equals 1, which is finite. Hence, 987.0 is a terminating decimal. Observe the last example. In 45.3333, the decimal digits are 3, 3, 3, 3. They repeat and never end. So, the number of decimal digits is infinite. Therefore, 45.3333 is a non-terminating decimal. I mean, it is not a terminating decimal. Got it? Now, let us understand why we call it a terminating decimal with an example. Observe here. All terminating decimals can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0, meaning the denominator should not be equal to 0. Example, 2.5 can be written as 5 by 2. For now, do not worry about how to convert the decimal 2.5 into the fraction 5 by 2. Just focus on understanding the concept why we call it a terminating decimal. Got it? First point, observe here, when we divide 5 by 2, we get 0 as the final remainder. So, you can say the division is completed in this case. Second point, observe here, the quotient or the result is 2.5, which has a finite number of decimal digits. So, 2.5 is called a terminating decimal. Got it? Tomorrow, we will explore terminating decimals in more depth. So, please stay tuned. Hi all, welcome again. In the previous video, we have discussed the basics of terminating decimals. In this video, we will explore this topic in depth. Example, 0.25 can be written as 1 by 4. So, 1 by 4 is the fraction equivalent of 0.25. Got it? First point, observe here, when we divide 1 by 4, we get 0 as the final remainder. So, you can say the division is completed or terminated. Second point, the quotient or the result is 0.25 or simply 0.25, which has finite number of decimal digits. So 0.25 is a terminating decimal. So the conclusion is, in case of terminating decimals, when we divide their fraction equivalent, the division ends or terminates after few steps. And also we get 0 as the final remainder. That is why the decimal has a finite number of decimal digits. So they are called terminating decimals. Got it? Hi all, welcome again. Yesterday we have discussed about terminating decimals. Today we are going to learn about non-terminating decimals. The definition says that non-terminating decimals are decimals that have an infinite number of decimal digits. It is meaning that the decimal digits never end. Got it? Let us try to understand the definition with an example. In 57.3333, the decimal digit 3 keeps repeating and never ends. So, 57.3333 is a non-terminating decimal. Got it? Observe here, 57.3333 can be written as 57.3 bar. A bar over the decimal digit 3 indicates that 3 repeats infinitely. Got it? Next example. In 0.272727, the decimal digits 27 keep repeating and never end. So 0.272727 is a non-terminating decimal. Observe here, 0.272727 can be written as 0.27 bar. A bar over the decimal digits 27 indicates that 27 repeats infinitely. Got it? Observe here, in the first example, the decimal digit 3 keeps repeating and never ends. In the second example, the decimal digits 2, 7 keep repeating and never end. So, in both the above examples, there is a repeating pattern in the decimal digits. Got it? Third example, the value of pi is 3.14159265 and continues. Here, the decimal digits never end and do not follow any repeating pattern. So, it is a non-terminating decimal. Got it? Fourth example, the value of square root 2 is 1.414213 and continues. Here, the decimal digits never end and do not follow any repeating pattern. So, it is a non-terminating decimal. Got it? Therefore, the conclusion is non-terminating decimals are decimals that have an infinite number of decimal digits. Observe here, the decimal digits never end or they are infinite, whether they repeat or do not repeat. Got it? In the next session, we are going to learn about different types of non-terminating decimals. So, please stay tuned. Hi all, welcome again. In the previous video, we have discussed about the basics of non-terminating decimals. Today, we are going to learn about different types of non-terminating decimals. Non-terminating decimals are broadly classified into repeating decimals and non-repeating decimals. First one, non-terminating repeating decimals. The definition says non-terminating repeating decimals are decimals that have an infinite number of decimal digits with a repeating pattern. Got it? Let us try to understand the definition with an example. We know that 2.3333 can be written as 2.3 bar. Observe here, all non-terminating repeating decimals can be written in the form P by Q, where P and Q are integers and Q not equal to 0. Therefore, 2.3333 can be written as 7 by 3. So, 7 by 3 is a fraction equivalent of 2.3333. Got it? Observe here, when we divide 7 by 3, the division never ends and the remainder never becomes 0. Got it? Also, the decimal digit 3 repeats endlessly, forming a repeating pattern. Got it? The conclusion is 2.3333 has an infinite decimal digits. Also, the decimal digit 3 is getting repeated endlessly, forming a repeating pattern. Got it? Hence, 2.333 is a non-terminating repeating decimal. Hi all, welcome again. In the previous video, we have discussed about non-terminating repeating decimals. Observe this example. Here, the decimal digit 3 repeats infinitely and it is forming a repeating pattern. Got it? Observe the second example. Here, the decimal digits 2, 7 repeat infinitely and forming a repeating pattern. Hence the name non-terminating repeating decimals. Got it? Today we will learn about non-terminating non-repeating decimals. The definition says that non-terminating non-repeating decimals are decimals that have an infinite number of decimal digits with no repeating pattern. Got it? First point, non-terminating non-repeating decimals cannot be expressed in the form p by q, where p and q are integers and q not equal to 0. Got it? Now let us try to understand the definition with an example. Observe here, the decimal digits are endless. So it is non-terminating. Next, observe carefully, they have no repeating pattern. So it is non-repeating. Got it? Hence, the value of pi, that is 3.14159265, is an example for non-terminating non-repeating decimal. Got it? Now let us conclude. Since the value of pi has an infinite number of decimal digits and no repeating pattern, it is called a non-terminating non-repeating decimal. Got it? This table gives you the difference between terminating and non-terminating decimals. Please make a note of them. Till now, we have studied about natural numbers, whole numbers, and integers. In the upcoming series, we are going to learn about rational numbers, irrational numbers, and real numbers. So, please stay tuned with me. Thank you. Till now, we have discussed about decimals. Under that, we have discussed about terminating decimals, non-terminating decimals, non-terminating repeating decimals, and non-terminating non-repeating decimals. Here are the main points about terminating decimals, non-terminating repeating decimals, and non-terminating non-repeating decimals. Please make a note of them. Thank you for watching this video. Please like and subscribe to my channel. Thank you.